mg cos theta. Mg is the horizontal component with which the body on an inclined plane is going to fall down. The force which pulls the body on an inclined plane, or when a body is inclined at an angle. Why this mg cos theta is the vertical component. All right, good afternoon. You're welcome to this class, and this is VINDAL'S concept. Remember, this topic, inclined plane, is a very big problem to many students, even teachers. So today, just give me some time. Let us dissolve the principle of inclined plane. All right. So this inclined plane, you are going to enjoy it. Just let's go. You know, when we talk about the inclined plane, we are talking about a staircase. And you are going to be watching the video I'm going to be pasting on the screen because it's going to help you to have a better understanding of what inclined plane is all about. But I'm going to show you because in an inclined plane, when the question comes, whether Waec, JAM, igcse, or any international exam, you'll be seeing things like this: mg sin theta, r mg cos theta, you see r and you see w. Now the question is, what are they and how do they play a part in an inclined plane? Let's go. Inclined plane is like this, okay? For an inclined plane, we have a load which is to be pushed on the inclined plane or which falls on an inclined plane. Now, this particular load has a mass and also it has a weight. And this weight is vertically downward, which I'm going to be giving as mg. Now, this mg is the weight or the force vertically downward, like we said. It has a vertical, this is a vertical component, all right, because the inclined plane came from a horizontal line, but inclined at an angle. So this is the angle of the inclined plane. Is this angle that determines the force with which this body is going to fall down, and that force is given in this direction, because this particular direction shows the direction for an inclined plane to fall through this plane. Now, what we are going to do at this point is to find where this F equal to mg sin theta comes into play here and what it does in terms of force diagram, and where mg cos theta also comes. But what we are going to do is, I'm going to find this vertical component, not really vertical component, the weight of this body, which is angle 90 with the horizontal plane. So if I have angle 90 here and I have theta here, so to complete a triangle, I'm going to have 90 minus theta. Sharp. So 90 minus theta here. So I've completed a triangle. Now, there should be a resolution. I'm going to resolve this force, which is mg. This mg is same thing as this weight. So I'm going to write mg. So they are the same thing, which is the weight of the body. I'm going to resolve this to the horizontal. I'm going to resolve this to the vertical. Somebody may be saying, why am I calling this horizontal? It doesn't look like horizontal. In physics, we are not really looking at horizontal component or horizontal axis as the conventional horizontal axis you know in maths. Look at what I mean. Because this inclined plane was just a normal plane on the floor, and this body weight is lying on it or is placed on the plane. This is the normal reaction, R. Why do we say it's normal reaction? It is the reaction of this plane on the body. But this body has a weight downward, which is W. But you see, just like this plane, if I inclined it at this point, then the load, if this was like this, normal, if I incline it, the weight is going to be in this form. The same thing that is going to happen to the inclined plane, to the normal reaction, this normal reaction is also going to incline at this point. So it's still going to be my vertical component. Now, I have it this as vertical. This is my vertical. In physics, what I call it is what it's going to answer for me because it's modeling. Sharp. Now, when I resolve this to the horizontal, I'm going to have mg sine theta. Because I have resolved this weight, which is inclined at an angle. I'm going to show you the angle. There is a vertical component as well here. Let me use dotted line. This vertical component then makes, I'm not going to put this for now. Let me keep it for proper illustration and analysis of this question. Now, see what happened. This is the vertical component, right? And this is the horizontal component. See the horizontal component. Now, what do I do with this? This is the vertical, and this is that same force. So if I make a line this way, parallel to this side, this is parallel to this, I'm going to have angle 90 here. If I have angle 90 here, this angle 90 minus theta is going to be here as well. 90 minus theta. Because it's going to be the what? Alternate angle. Then that means this place, to complete a triangle 360 degrees, this place is going to be angle theta, which is here. Remember, this is parallel to this side. So on that premises, on that context, I'm going to resolve mg. I'll resolve mg to the horizontal. I'm going to resolve mg to the vertical. If I resolve to the horizontal, I'm going to have mg sine theta. If I resolve vertical, it's coming here because this is the vertical component, which is y, and this is x. So this is going to be mg cos theta. Now the question is, what is mg sine theta and what is mg cos theta? Mg is the horizontal component with which the body on an inclined plane is going to fall down. The force which pulls the body on an inclined plane, or when a body is inclined at an angle. Why this mg cos theta is the vertical component. Go ahead. Finish what you have. Okay. So this is the vertical component. This vertical component is the same thing as the, sorry, I'm supposed to write. Well, I didn't. I'm on video. So this is the normal reaction, which is equal to the vertical component of the force. Now, this vertical component of the force must be equal to this, especially when the body is on equilibrium. That is it. Then this is the horizontal component of the force with which the body is falling down the plane. If I happen to put any other force, this is going to be a force which is there to push the body onto the or up the plane. Why this is the weight, and this is the angle of inclination. Why this is the normal reaction. These are the forces involved in an inclined plane, which makes it what it is. Just keep watching because I'm going to solve a question where these principles are going to be employed. Thank you.